So today's lecture is going to be a little bit different. I'm going to do a live demo throughout the lecture. So we'll see, anything can go wrong. Maybe I'll fail, maybe I'll succeed. We'll find out in time. But if you have ideas, there are people who were announced this earlier, so people who are already here are shouting out ideas of what you want me to code in this lecture. So I'm going to try to crowdsource this and get ideas from chat and then build something of your ideas. It should be something that fits the state pattern. So anything that is going to change change behavior based on its state. Calculator was already said. I mean, it's yeah, funny, but so anything that changes state. We're stuck on appliances right now. Appliances are fine, but appliances, I already hit you hard with the appliances in my lecture questions and in the homework. So if you want to do something else, would be nice. But if not, whatever. Artificial intelligence, yes, but can I get more specifics there? Tesla autopilot, that could be fun. Autopilot. But before we start thinking of a fart machine, come on, Mango Mutiny. Like what different behavior would you get? A fart machine farts. That's it. Like one state. I'm done. Follow them. If you're gonna try to be funny, at least follow the format. Come on, man. Put some effort into it. So today's lecture question. We're simulating a car. I won't go through this whole thing because I want to get to the demo. We only got 50 minutes and I want to try to finish the whole thing. I want to walk you through my thought process of solving a state question using no conditionals, of course. I'll ban conditionals, control flow conditionals and loops, and try to finish something with different behaviors using the state pattern. So today's lecture question, car, you're given the API again. Only call these methods in your test, just like last time. And you should have some behavior based on which gear the car is in, so you get an idea of what the states are going to be. And the car should have different behavior for these API methods, depending on which gear it is, and different gears that it can shift into. It was brought up in office hours yesterday, and I want to make sure I say this. When you get to these lecture questions are made to prepare you for the homework assignments, the microwave and calculator. Microwave and calculator are much more complex than any of these lecture questions. With each lecture question, it's pretty easy to spot what the states are going to be. Even for this one, even just at a glance, you can tell the states are going to be, park, drive, reverse. You can be in these different states. And then there are a few kind of hidden states that you have to think about for this question. So we're getting a little bit into that. But when you get to the calculator, you can't immediately tell what the states of the calculator are going to be. So it's much more difficult to come up with those states. The API, again, is given for you. It's just all the buttons on the microwave, all the buttons on the calculator. But what the states are is the new challenge for the homework. That's where it's really going to test, can you actually design using the state pattern? So some of you are finding out that when you jump into the homework, there is that big step up in difficulty, and you will see that. That's by design, lecture questions, and then a big step up in difficulty to go to the homework. But you will see that in the deciding which states should even exist part of the assignments. So we talked about state pattern for a while. I just want to wrap up what we've learned about this. The big thing about state patterns is there are trade-offs. There are pros and cons to this. This isn't just the state pattern is something you should use everywhere. I'm never going to say that. I never will. This is something that I'm using to show you the benefits of inheritance and polymorphism and how they can be used to solve problems in a different way. I'm not saying that way is better. I'm not saying it's worse. I'm just saying here is another way that you can solve problems. And when we move into functional programming, we'll do the same thing. We'll see different ways of solving things using functions as our root way of thinking instead of as objects. So the pros, it's going to organize your code a bit better. If you have a large, complex design, it's easier to reason about that design and actually get a good structure with your code. And it's a lot easier to actually implement your code as well once you have that design. Each state, you're implementing each method. So whenever you write a method, you're just thinking very narrowly. If my object is in this state and this method is called, what should it do? That's all you have to code for each method. Some of the cons, you're going to have a lot more classes. You're sacrificing some method complexity. We might have very complex methods without the state pattern, but we trade that off for many more files, many more states. In the project structure, when you open the directory in the project view, there's just a lot more going on, and it can create some pretty good spaghetti code where you have to follow around. You have to jump from class to class to class to figure out what the behavior is during certain method calls. So there are definitely some cons as well. So it's more of thinking, what's the best approach for the particular problem that I'm given? Of course, for these lecture questions and the homeworks, I'm forcing you to use state pattern. Functional programming, likewise, I'll force you to use functional programming approaches. But after that, it's up to you to think, what should I use here? Should I apply the state pattern? Should I use some recursion here? Should I use functional programming? What should I use? I think I hit on these. I want to get to the demo. So let's do some live coding, and of course the lecture question. Where's my mouse? So we got some ideas out here. P, I don't care about the Ferrari and how fast it can go. But oh, I see. You're talking about the lecture question. All right. I'll give you that one. It's somewhat related to the lecture question. That's how we got there. But I still don't want to watch the video. Maybe off duty. If else. Oh, learning objective. Thank you, Kurito Kataki. So I did post the learning objective, the initial results right before lecture, like an hour before. Go to Autolab and click on under learning objectives, click program execution, and you can see at least your preliminary scores for the 3 categories. And for some of them, I did verify as well. So if you have all 3 and verification, if you have that verification, that means you've completed that learning objective. You don't have to worry about that anymore. If you are missing any of them, like for example, if you're missing code writing, it just means you didn't finish your lecture questions, and we didn't see any reason to waive any of your lecture questions. Some of you didn't finish your lecture questions, and we still gave you the code writing. That means you can forget about those lecture questions. You can still do them for practice. I always recommend that. But I have 0.0 at read. What did I miss? Come on, man. What am I supposed to answer that during lecture? Which part of my spiel is actually saying that if you click on your score, there is feedback for some of them, but not all of them. So on your read, I think we do have feedback on those. You just click your 0.0 and it'll tell you. So take a look at those and see what you have to do. If you miss the lecture questions, you can still do those lecture questions, just still complete them and submit. You have till the end of the semester. So that one, you know what you have to do. If you didn't get the code reading, I believe all of those do have at least some comments. Some of the comments just say you don't understand stack and heap, which if you don't have credit for that one, then you just didn't understand stack and heap. For that one, there will be makeup opportunities during future labs. The next opportunity will be during the functional programming lab, the Thursday lab for that. So in 4 weeks, we're going to have that lab, and there will be stack and heap questions on that lab. It's just naturally part of the functional programming content. And if you do well on those questions, we're going to go back to your learning objective 1 and mark off your lab for that. So you'll just naturally have an opportunity. Just keep studying, keep going through the course as normal. And you won't even have to do like a makeup opportunity. You'll just do that learning objective 3 lab. And if you knock it out of the park, we're going to go back and use that as evidence for your learning objective 1 when you just naturally do learning objective 3. For the interview, the head TAs will start reaching out for makeup interviews. I don't have a solid time frame on that, but I'll say roughly mid next week we're probably looking at to start contacting you and reaching out for some makeup interviews. The interviews, we may also have makeup opportunities in future learning objectives, just so we're not scheduling too many interviews. We don't want to make you interview 15 times for a couple of things to check off. So yeah, I'm glad you mentioned that because I wanted to talk about all this. And yeah, why you all... Never mind. I don't want to go down that one. Yeah, and if you misexplain there, I don't think we had much feedback on that one. But we looked at so the TAs that you interviewed with gave you a score for each one of the questions based on how well you explained it. And then we compiled all those scores based on the questions that you got through on the interview, and used that score to determine the cutoff. So if we just weren't super, if you were really shaky on the content, you got that 0.0, and you got to try again. You got to show us again that you understand that content. All right. Got that one done. TA's very generous as long as you know what you're dealing with. Yeah, that's pretty true. We're really not too rough on this stuff, but you got to know the content. Like I've spent a whole week talking about stack and heap. If you can't even explain like what a stack frame is, you know what you did. You know why you got that 0. The lecture questions the only way to get the right credit? No, you can also, we override some lecture questions, or we waive some lecture questions. For example, if you did the homework assignment, if you got AutoLab, if you satisfied the AutoLab part of homework 1, then we can use that as evidence to waive some lecture questions. But the lecture questions are the guaranteed way. You get complete for all 6 lecture questions for the learning objective. There's no question. You got credit for that writing part. Nothing else needed. But if you can't get all 6 of them, there are other opportunities through the code that you write in the class. Verification is just the homework, right? No. Bite, come on. Read the syllabus. I'm sick of answering syllabus questions. It's the end of week 5, people. Are we going to cover MVC soon? That's later. But all right, so let's get on to some. Can I still get credit if I got a 0.0 for explain? Yes. So let me be very explicit about this. If you didn't get credit for learning objective 1 right now, if you don't have credit for it, that doesn't mean you failed the class. Like, you have to complete that to pass the class. I'm not saying everybody who has a 0 for any of these 3 things just failed. So of course you can still get credit. And I feel like I just explained how. But, all right. So I'm just going to get frustrated if I field questions like that. So let's go through this. We got some ideas here. I think I'm just going to pick one just for the sake of time so we can get moving. Let me think about each one to see how interesting the question will be. Tesla Autopilot, how would this be states? Like, the inputs could be, I'll kind of think about the API of each one and the states a little bit to see which one will be good for an example. Tesla Autopilot, I like it, but I think it's going to be too complex unless we oversimplify it. If we oversimplify it, it won't be interesting. So we could have an API like sees obstacle in road, and it can change lanes. Maybe the state is left lane, right lane, center lane. And if there's an obstacle in one of the lanes and it's in the center lane, it'll switch between one of them. Sees pedestrian, keeps driving. We're going to build a proper autopilot if we do that. Maybe we could do that. The states are which lane it's in. Fridge with Bluetooth. What would I do if I had my fridge connected to my phone? What would I even do with that? I don't know why I would want my fridge connected to my phone. So I don't know. Like, a fridge should just stay at some constant temperature. Maybe I can increase and decrease the temperature. But how often would we do that? In what situations? And the fridge behavior wouldn't really change. Is there something... Oh, watching what's actually in the fridge? Oh. Ooh, that could be good. Maybe we can do this one. We would... maybe we pick a meal. I'm trying to highlight this. Maybe we pick a meal with certain ingredients, and then depending on which ingredients are in the fridge, we'll have different behavior. So this would be like pudding. Okay, there. I don't want my toilet talking to my phone either. I don't know. I just don't. I don't get the fascination with all this stuff, having everything connected to your phone. But maybe that's just me. Um, Plus, I use technology way too much already. I'm trying to cut back on my use of technology. I don't want anything connected to my phone or anything that doesn't need to be. Telling who stole my pudding, we could do that. Gumball machine, I like it, but I at the same time I don't like it because uh, one of the questions I like to use on the OOP lab is, spoiler alert, but is a vending machine. And gumball machine would be basically the same thing. You can insert coins, you can ask for your change back, or you can dispense of a gumball. So I don't like that just because I don't want to give you the solution. Or maybe I do. Maybe I want to reward you for watching lecture. So I'll put a strong maybe. Actually, no, I don't want to because I already have the solution in my head because I've used that question a lot. A washing machine, if it's maybe dishwasher. I think I'm liking the fridge option. Let's make a call just so we can get moving and get to the good stuff, and do a fridge. So let's come up with a spec sheet. What kind of behavior do we want from this fridge? Detect when. I don't know where we're gonna go with this one. Detect when pudding was stolen. I don't know if we're gonna be able to tell who stole the pudding without coding people classes and a lot of other stuff. Increase. Whoa. Increase, decrease temp. Change ice mode from crushed to chips. Oh my goodness, whenever somebody changes it from crushed to cubes, are the two, drives me nuts. When I get my ice and it's just these big old chunks of ice coming out. Oh man, crushed always. Crushed versus cubed ice. I don't know where to go with the pudding one, so I'm gonna scrap that idea. As much as I want to get something more funny in there. Increase, decrease temp, sure. Connect your phone to the fridge. You have speakers in your fridge. Tell me that doesn't exist. I know the answer. It's gonna exist because everything does. But speakers in your fridge? Like, just get speakers and a fridge. Those are two things that we have to, like, if I was buying a fridge and the salesperson was like, all these fridges have speakers and you have to pay an extra $100 for the speaker functionality, I'd be like, I don't want to pay for that. I don't want speakers in my fridge. I have speakers all over my house as it is. So I just out of rage, I'm not going to do the speaker part. And an alarm. Yeah, and an alarm on your fridge, same thing. Those features don't belong in a fridge. Toilet. Whoever said fridge idea now gets an automatic A. Congrats. Yes. I will. Oh, too bad you're anonymous. Too bad. Pass the class. Fridge. Change temp if outside temp changes. Change temp based on outside temp. I don't think we can get the pudding thing in there. Crush too loud at 2 a.m. Deal with it. I need my crushed ice. Defrost. Maybe we can add a defrost. Oh my goodness. I can't type as it is, but with all the pressure, it's tougher. An Alexa faucet. Why would you? An Alexa faucet. You know what? I'll grant that one. when your hands are all, when you're chopping something up or mixing something, your hands are all messy. You don't want to touch the handle and get it that messy too. Alexa, turn on water. You know what? I would actually use that. I can see some benefit of that. Expiration date on... I don't know. The expiration date might be... That's going to really beg for a conditional to check if the date is out of date. I like it, but it's not going to fit the state pattern very well. Okay. Oh, yeah, CompSec. Yeah, I was hoping that your fridge didn't do all that. I wouldn't be surprised if that all exists, but I would be surprised if multiple people bought one. Okay, so let's door open, close. I hear you, microwave. Club microwave here. Door open, close. All right, I think we got enough. We got to start designing this thing. Light on when door open. Okay. Light. Okay, so let's work on this. Ice can be dispensed is either crushed, oh my god, or cubed. User's choice. Temp can be increased, decreased to any of, we'll say 5 different positions. Which are, oh my goodness, 1, 2, 3, 4, 5. Which should be reminiscent of Wednesday's lecture question. Change temp if outside temp is cold. Set temp to 4. If outside temp is warm, that's backwards. If it's cold out, I want warmer stuff. Is hot. Set temp to 4. Defrost. I don't know how to implement defrost. If we have an auto defrost, we kind of have to factor in time and ask how much time has passed in order to defrost. So we could have a defrost button, and maybe that just changes the temperature to 1. But then how do we go back from 1 back to the previous? Maybe it's a defrost. Can we have this as a switch? That sets the... We'll have that just set the temp to 0. Looking at you, mute button on the TV. Door open and closed. Open door turns on light. Open door deactivates all the ice. You can't get ice while the door is open. Okay. I think we got plenty of functionality here. At 2:15. Notify if there's an internal problem. Maybe the outside temp has states. Yeah, I'm already thinking of states for the outside temp. Okay. Me crying Poverty. Oh man, I can't afford a fridge with an alarm on it. I'm okay with that. If that's what poverty, if that's the only thing poverty means, I'm okay. All right, so let's define the API. So I want to look through these features and pick out what the API is going to be, so I can get an idea of what these methods are going to be just by looking through these. Ice can be dispensed as either crushed or cubes, user's choice. So I'm going to say get ice. Switch. Let's say switch to crushed. Switch to cubed. Temp can be increased or decreased to any of 5 different positions. Initial 3. Initial crushed. Screw you, cubed people. Get ice. So temp can be increased. So increase temp. Decrease temp. Get temp. Temperature change based on the outside temperature. I don't know if I'll have these. Yeah, these will end up being states. But there'll be API methods as well. So if it becomes cold outside, we're going to call the cold outside method. Hot outside, we're going to call the hot outside method. Just to simulate that. So we're not going to simulate the environment and the weather and everything. But we do have methods cold outside and hot outside. And we should note that this, when it becomes cold or hot, it's going to set the temperature to 2 and 4. But we can also increase and decrease the temperature after that. So if it gets cold and we switch into the cold state, we're going to set that to 2. But then if I increase the temperature, I don't know which way I'm thinking on this. I think I do want it this way. I'm thinking the higher number is colder, was the way I was thinking initially. But let's say the higher number is hotter. Cubes for waste. Oh yeah, cubes for, yeah. That's one case, but assuming you're 21 or over. Defrost. You know what? Let's cut it off. Actually, I do want open door and closed door. Open. Actually, this is already a lot, isn't it? Crush cubed. I already have a lot of states. If we get to the doors, we'll do it. Get ice, get temp. And is light on. Alright, so if we get to those ones, we'll get there. But I want to get some states in here. So I'm going to look at all of this behavior, and I want to know in which scenarios can this fridge be in where we have different behavior. Oh, man. Select. Delete. So let's start coming up with our states. I'm going to name one state just in it for my initial state. And I want to define what, oh my goodness, select. And I want to say what happens in this initial state. Once I hit a button, so if I hit get ice, get temp, is light on, my kind of output methods, I'm not going to get any change in behavior. When I'm in the initial state, ice is going to be crushed, so this isn't going to change any behavior either. But once I hit switch to cubed, now I'm going to have a state transition. So switch to cubed. This method call is going to give me a state transition. Can I get an arrow on the end of that? Oh, that's gonna be ugly. I am the best artist ever. Just wanted to let you know. In it, we'll say in it. No, we're not gonna name it in it. We're gonna name this cubed. And if that's how we're gonna name our states, I want to go back to init and name this. Man, it's annoying. I gotta switch to select every time. And I want to name this crushed. So I know that when I hit switch to cubed, we're going here. Switch to crushed, we're going the other way. This is going to be a mess of a diagram. I never should have opened up Paint and even tried this. Increase temp, decrease temp are not going to change any of the behavior. It's going to change the temperature, but the behavior is not going to change. If I increase the temperature of this fridge, whether it's crushed or cubed, making crushed or cubed ice, none of these methods are going to change what they do. So I don't have to do anything there. The only difference is if I increase and the temperature is already at 5. But as we saw in Wednesday's lecture question, we can get around that without an extra state. So these are not going to cause any straight transitions, so I'm not going to need any new states there. Get temp is a getter. That's not really going to change behavior. And then cold outside and hot outside. This is going to change our behavior a little. So for example, if I call cold outside, all it does is set the temperature to 4. But then I can override that. I can lower the temperature back down to whatever it was. If it's cold outside, it's going to 4, and I lower it back down to its initial 3. And then cold outside is called again. It's not like it became cold outside again. It just is still cold. So I don't want that to reset back to 4. So I don't want cold outside to just always say temp equals 4 now. So I am going to change a state. So I'm going to have a state for cold, and I'm going to have a state for warm, or hot, rather. Should we say, you know what, I want an initial state here, don't I? Let's just simplify something down the road. We'll say it's initially cold out. Just so I don't have to have hot, cold, and initial states. So we'll name this crushed cold. Of course, I have that advantage that I can change the specs at any time. Oh, I'm living with that. If it bothers you, I'm sorry. Because I want to get to the code. Most of the time is spent designing in these questions, but I do want to get to that code still. So, and then we're going to have a crushed hot. Cubed cold. I was referring to going over the edge of the box, but having that state named the wrong thing, that one I do have to fix. So I guess we will fix it all. I didn't even notice I typed the wrong thing there. Cubed cold. Cubed hot. And we have to add our extra state transitions here. If we I should have probably did this in like PowerPoint. And I have a transition here of what did I call this? Hot outside. Hot outside. Over here. Over here. Cold outside. And some arrows. Cold outside when it's hot is going up here. Cold outside when it's hot. Oh my. I'm going to try to perform surgery right here. Beautiful. Beautiful state diagram, if I do say so myself. I don't know if anybody is capable of creating a better state diagram than that one. So here, I don't have any more states until we go to open door and closed door. And here, I want to emphasize one of the downsides of the state pattern, especially if we take it to this extreme where we don't have any conditionals. If I want to add this open door, which given more time we could add that. If we want to add the door opening and closing, guess what we have to do is double this state diagram. So if we're strictly using states and no conditionals to be able to control this stuff and not getting creative, we could have multiple state variables inheriting and multiple inheritance trees. We could do something like that. But if we're sticking to a single state abstract class and then extending it, then we have to double the number of states each time we have a new Boolean condition that can change in the state. So we'd have to have crushed, cold, door open, crushed, cold, door closed, crushed, cubed, cold, door closed, cubed, cold, door open, etc. for the other two, and then have all these state transitions being able to switch between the respective states for those. So when you do add new features, like when you're adding that decimal, when you're adding some door open, door closed in the microwave, these homeworks are designed so the states don't get out of hand, but there will be some duplication, like we saw with the double jump, where we had two states that had to change, that had to create new states. Double jump before double jump and after double jump, and whether you're rising or falling, we had to have these extra states. And if we had any state in the actual player itself, we want to track, like, is the player's that's a bad example, if the player's crouching or not and allowing crouch jumps, then we have to double all of our states. Every state has to have a crouched and not crouched version. So these states can get out of hand if we fully commit and we overcommit to using the state pattern, which of course you wouldn't do in practice. You would pull in conditionals when they're needed, so you don't always have to use all state pattern all the time. So let's get to some Intellij, where I have a project partly set up, and I didn't set it up all the way just so I can do a nice demo, another demo of setting things up. What I did was just pasted a template of a test. Where's my code? I pasted a template of a test, and I pasted the pomx.xml from the project. That's all I did after clicking new. Oh, you can't see the menus, but file, new project, and I just set up a brand new project like that. So with the POM, I forgot you can't really see the POM, but I clicked that magnifying glass, search for Maven, did add as Maven project, and that's going to bring up Maven on the sidebar because that wasn't showing up before. And then everything installs, Maven does its thing, errors go away. Cool. So now I'm ready to write some tests. Before we do that, let's at least create package. What are we doing? A fridge. New Scala class. Refrigerator. Oh my goodness, I did not spell that right. Refridge. I should have just called it fridge. I am not a spelling professor or an English professor. Fridge. And we need these methods inside the fridge class. So def. Oh no, I'm not on my Mac. What's the shortcut? There we go. Auto formatting is always your friend. And right now they're just going to do nothing. Get ice. Let's say this returns a string. Crushed. Does nothing. I had a typo. Get temp is going to return an int. We'll just say that's 4. We know that's what it is in the initial state. Cold outside. Auto format. And now we can write a test. Test the fridge. Val fridge equals new fridge of type fridge. And I'm just going to do one test. Here's where we would write our whole test suite. I did Control-Alt-L for auto formatting. It's a lifesaver. I love it. I use that shortcut more than most any shortcut. So I can just type all crazy, auto format. My code looks pretty. So this is where we would use TDD like we are in the labs, where we would build our whole test suite. We would write tests for every piece of functionality that this fridge can have. I'm not gonna go that far, but let's at least set up one test, just in the interest of time. I would like to, but just in the interest of time, assert fridge dot get ice equals crushed. Assert fridge dot get temp equals 4. Fridge dot switch to cubed. Fridge dot decrease temp should be 3. Fridge dot cold outside should remain 3. Fridge dot hot outside. Fridge should go to 2. Fridge dot decrease temp 1. Fridge dot decrease temp should remain 1. We should have a min value. So we'll get some just some basic testing. But let's write this fridge thing. So let's get to the good bits here. Let's get to our state pattern and code this thing up. So we want some state. I usually like, this is more preference, but I like to put my states in a separate package. And then keep that separate from my actual object that I'm working with. Fridge state. Grab my API methods. Var state of type fridge state. Auto imports for me equals new crushed cold. Crushed cold extends fridge state. These are going to be abstract. I'm going to make my base state class abstract as well, because we can't really create a fridge state. We can only extend it. Where did my, oh, right. And then I have this nice autocomplete that's going to implement those methods for me and give me some default undefined behavior. Crushed cold, come on. There's no time for this. There we go. And we want to defer this dot state. All our functionality, we're going to defer to the state. No real easy way to do this. We're just going to do some cut and pasting. Why is it asking for strings there? So all my functionality in my fridge is just going to defer to the states. And I know I'm going to have at least one variable to store the temp of this thing. So the temp is an int. I know it initializes at 4, so I'm going to set it to 4 because I'm starting in that crushed cold. On Mac, it's Command Option L. I feel like I might have overridden the defaults on that one. But that's what I press, at least. And then we want to create this. I'm going to copy this for each of our... Wait, before I do that, I want to get some default behavior of nothing here. Just so I'm not doing this for each class. Get temp is probably always going to... Oh, crap. I forgot. So each state needs to know the object to which it's attached. I forgot my fridge here. Why do you say Alt-Enter when that's not... Well, that's not what I'm supposed to do. And since these variables are both in the constructor, we can reuse the same name of the variable that we inherited. Get temp. So get temp is always going to be fridge.temp. I don't think that's going to change in any cases. So now we can create our other states. Crushed hot. Oh my goodness, we're 2 minutes over already. Looks like we're not getting there, but I'm going to keep keeping on here for those of you interested. We got the design part down at least. Cubed cold. Duplicate. Yeah, I have a lot of duplicate code right now. So now that we have everything set up, we have all of our states. Now is the easy part. We just go through each state and decide what happens in each state. So if I am in crushed cold, it's cold out. I don't really care about that. I only care about that to, actually I kind of do. But get ice, I'm in crushed. Switch to crushed. We're already in crushed. Does nothing. Switch to cubed. Fridge dot state equals new cubed cold. So we're in crushed cold, so it's gonna stay cold, but cubed is going to change, and give it that reference. Increase temp. Fridge dot temp equals math dot min to get our max of 5. Fridge dot temp plus 1. Decrease temp, same thing but backwards. Fridge dot temp equals math dot max of 1 and fridge dot temp minus 1. Lost some characters there. Get temp is always going to return fridge dot temp. Cold outside does nothing, it's already cold. Hot outside is going to transition to the crushed hot of fridge. Oh, I hit insert at some point, didn't I? That's why I'm getting messed up on that. And then auto format is our friend. And we have our class. Now some of this behavior is going to be the same no matter what. Get temp, decrease temp, increase temp. I'm going to pull all of this code out. I don't expect that to ever change. So I'm going to pull that out and add that right to the state class itself. Oh, without overrides. Now I don't have to retype that in every class that I create, that I edit. I'm going to delete these. Boop. And get that shared behavior between all these. Crushed hot. It's going to be similar to crushed cold. Here's where I might use some inheritance to switch things around. Whenever you're cut and pasting large blocks of code, that's a good sign that you should have use better inheritance and encapsulation. The only difference here is hot does nothing, but cold does change to the cold state. And I forgot on the other one. fridge dot temp. Whenever we transition into cold from hot, we're going to set the temp to 4. Whenever we transition from cold to hot, we're going to set this to 2. So this behavior is going to be the same here. This behavior is going to be the same here, which is a good indication that we should reorganize things. Again, we're overcommitting to the state pattern with this. This isn't necessarily how you would do it. And even then, I might have 2 different states, one for the temperature and one for the ice. Since the temperature and ice are completely independent of each other, what I would really do is have 2 different states, one for the ice state and one for the temperature outside state, and then have 2 different state abstract classes. That's how we could get rid of some of that. But you know, we're doing what we can with limited time. Ice. This is going to be exactly backwards. So let's do cubed. Switch to cubed, does nothing. Switch to crushed. It's cold, so crushed. Cold. Crushed. Hot. I think you'll agree, none of those methods were difficult to write. They're mostly all one-liners. And the moment of truth. Let's see if our test passes.